So in this lecture, we're going to be looking at two cases that are lecture-only cases, not the cases we're going to be discussing in class, but they can become quite useful for highlighting some of the conditions and mechanisms that contribute to basically errors and negative outcomes or positive outcomes in some cases in risky cases. So let me give you a quick background on the cases that we're going to be looking at for that. Basically, we'll be looking at an emergency response system called the incident control system and the aircraft carriers, so air traffic control and aircraft carriers. So the incident command system, first of all, which is a system that is in widespread use really across the United States, and it's used to coordinate emergency response activity by multiple organizations. So if you imagine something like one of the recent hurricanes we've had, or one of the wildfires that is currently often in this type of season in California, what you can see is that it's often the case that you don't just have, say, the firefighters responding. You also have medics. You might also have people, say, associated with the power company and other types of organizations. You might have the Red Cross involved. And so these organizations often find a way to work together to sort of form a single organizational effort, in essence, on the ground because of the fact that they need to coordinate their activities. You don't want people replicating. You don't want medics going into places where there might be a sudden fire that could actually kill them, right? So you need a way to control all this. So in essence, what you think about the success requirements of this program are that you need to be able to recognize and adequately respond to threats to life and property, usually under these intense and pressured conditions. So again, that's part of the idea is that there might be some people, say the firefighters or the weather experts, who are quite good at recognizing what the threats are. But there needs to be a way to get that information so that the people who are doing other types of activities that are also associated with protecting and saving lives, that they can respond adequately. So there might be some groups doing recognitions, others doing adequate response. So in order to minimize error, there needs to be ways that these different activities can be coordinated. So the idea then again is that the success, if we think about this in an input-output sense, we have people and supplies, we need to have a coordinated emergency response, and therefore the emergency should be over with a minimal loss of life and property. So this looks very much like our initial firefighting case. The only difference here is that they aren't simply fighting the fire. Now what you need is coordinated across a quasi-organization, a sort of temporary organization. We need to have this coordination in which each of them is doing their own activity or function that they need to ensure that the emergency becomes over with a minimal loss of life and property. So what the incident command system does is basically set up a pretty standard work organization, right? So you think about the fact that they come up with the idea that there are these 5 basic work functions, like the command, which is setting the primary goals. So we could think about this being like the strategic apex or the strategic apex. You've got planning, developing action plans to accomplish objectives, very much the techno structure. You've got the operational core, which is just operations. So the people who are actually on the ground doing the things like fire suppression, ventilation, medical, hazmat, evacuation, search and rescue. You've got logistics and finance and admin, again, sort of falling into technostructure or support staff in the Mintzberg sense. But the idea is that, in essence, you've got the sort of core value add operations, and you've got these additional 4 things. And so part of the idea is that in a very small fire, in essence, all of those command functions and support and technostructure functions can be maybe done by one person. But you get a larger organization with or a larger incident with multiple organizations involved, you need to start breaking these out in a particular type of way. So in essence, what the incident command system does is it sets up this idea of here's what a fully fleshed out organization looks like. But in essence, it doesn't mean that each of these functional roles, and these are very much functional roles, right? Imagine this looking like an organization that could exist with a single person in each functional role, but instead what that you have in the incident command system is that the same person can play multiple roles. So the incident commander could play all of the roles as the head of operations, the head of planning, the head of logistics, head of finance and admin. But as you start to have, say, somebody working over multiple days, I mean, a large disaster working in multiple days, you need to start to actually take some of those command and control functions and, in essence, parse them out or delegate them down, and having the right people in charge. In addition, you might have something like an information safety liaison right here that is, in essence, the person who's like a press person. So again, a very small incident, maybe the head of the fire crew that responds, or the head of the fire truck, the chief, is in charge of that. But as you get a larger one, the people who are actually in charge can't take the time to work with the press or work with local organizations as sort of dealing in terms of information safety, tweeting out, where people can go, et cetera. And so you need to bring in specialized personnel. Again, the operations group you can think of as being, these are the people on the ground doing the work. So it's really in these additional 4 areas or 3 areas of planning, logistics, and finance admin where you're going to tend to get the most flexibility in terms of adding or subtracting additional personnel. But the ICS isn't simply an organizational structure. There's also not surprisingly, a work process associated with it. And this work process is basically for how you actually fill in the different positions. So the idea is that it's a standard workflow where an initial unit's going to respond. The head is going to become the temporary commander. That person is going to assess conditions, because remember, the idea is they need to be able to assess conditions. They'll say something like, oh, this is a hazardous materials type situation. Maybe we should have a different person in charge. So in that case, if the condition is that, well, it's a hazardous materials, we don't have a great expert right now who's the commander, they then switch around and change commanders. Or maybe you say, we are now expect to have at least 10 different units on the ground. We better have some more management functions. One person can't do all 4 major management functions. In that case, you're going to delegate out and assign different functional roles. So as you assess these conditions, you might also be put out a call for additional units. So the idea is this is an ongoing process in which there's a continual reevaluation of conditions. And as that happens, the actual who fulfills the roles, there's basically an org chart that gets shared that can grow and shrink as conditions warrant. It's a pretty remarkable process, and according to the case material that we have, and from what I understand, works quite well to keep basically this quasi-organization alive and working during a short-term disaster response effort. Now, let's look at the other case we're going to be looking at. This is another example of risky program deliver, which is basically aircraft carrier, a naval aircraft carrier, and looking at air traffic control on a naval aircraft carrier, which is slightly different than some of the other aircraft, the commercial aircraft that we'll be looking at in the major case for the week. So here the idea is that you're providing air support for the U.S. Navy. It's a very basically small little area, and you're getting up to 200 sorties per day. So you're getting like 200 different flights that sort of take off and leave. So you can think about it as the big functions are going to be launching these aircraft up into space, monitoring them, and then returning them back to the ground. And the program requirements are basically failure-free operating performance. So you don't want to have basically ever. You don't want to have no accidents with unacceptable consequences, even during very high volume. So again, even during war, you don't want to have the loss of life on the aircraft carrier. You need to be minimizing or basically almost completely, you want to minimize anomalies, as we're going to come back to, and you actually want to basically eliminate error. So again, a basic functional breakdown here. So it's not as spread out as here. We're only looking at the primary activity. So we're basically looking at the operational core here of the naval air operations. And so you can think about the functional processes here that we're sort of thinking about is moving the planes around the ships, so sort of getting them in the right place, both before they take off and then afterwards to store. You're going to take off some landings, and then you'll have actually monitoring them while in flight, and that'll be air traffic control. Even though air traffic control will also be monitoring takeoffs and landings. Another way, though, and that's important to think about that, is that there are different tempos at work here. This is actually true, in essence, of many enterprises. It's just particularly pronounced here in the case that we look at of the naval air operations. So imagine that there's some cases where there's only going to be one flight going out. There's going to be like an hour to the next flight. People are sort of, it's in a downtime. So there's a lot of, in the background, moving people around, etc. But there's not sort of this sense, oh my God, a plane's about to land, another plane's about to land. Higher tempo, in essence, oh my gosh, there's another plane about to land, oh my gosh, there's another plane about to land. And so the landings are quick and rapid, with very little room for error as the tempo gets higher. So you can imagine this is like a very crowded store. If you're working in a store where sometimes it's very low and you're just going around rearranging things, putting clothes back on the rack maybe, or sort of cleaning up your whatever smoothie counter. But then in this higher tempo operations, you in essence have to just keep going as fast as you can to deal with each product. Now you might also have emergency tempo. This is when something bad has happened, or when, say, the weather gets quite bad, or something that is actually even more stressful and less routine than just a simple routine high tempo operation.